we going to see that transformer. It is a device which converts value of AC voltage from low to high, that means step up, or high to low, that means step down. Such type of transformer are called as an step up transformer and step down transformer. It consists of two coils. They are insulated from each other and wounded on a soft iron core. The first coil is called as a primary and second coil is called as a secondary coil, which is as shown in figure. Suppose magnetic flux in primary coil goes on changing by applying AC voltage. The magnetic flux in secondary coil also goes on changing, and here is a development of induced EMF. Now we consider that phi be the magnetic flux linked per turn for both coil at any instant of time t, and let Np the number of turns in primary coil and Ns is the number of turns present in secondary coil. Then when we apply AC voltage across the primary coil, then magnetic flux linked with this primary coil goes on changing. Due to this, here again magnetic flux linked with the secondary coil goes on changing, and EMF is induced here, which is either step up or step down. Or also we can say that this is called as an input coil and this is called as an output coil. Hence, magnetic flux linked with the primary coil N P into magnetic flux per turn phi, which is equal to, we can say that this is a magnetic flux linked with the primary coil. Similarly, magnetic flux linked with the secondary coil phi S is equal to Ns into phi. Suppose this is equation first. By applying Faraday's law, we know that EMF induced in primary coil EP is equal to minus d by dt of phi p, or this is equal to minus d by dt of Np phi, or this is equal to minus Np d phi by dt. This is equation second. And also for secondary coil, this EMF induced in the secondary coil is nothing but minus d by dt of this phi s, which is again similar to this minus d by dt of Ns phi, or this is equal to minus Ns d phi by dt. Equation 3. This secondary EMF Es is equal to Ns d phi by dt. From equation 1, 2 and 3, this EMF induced here in primary and secondary coil, or if we take the ratio of this EP to AS, this is equal to what? Np upon Ens. Suppose this is equation 4. This equation is known as transformer equation, or it is also if the ratio of primary to secondary coil, that means number of turns present in primary to number of turns present in secondary coil, then it is also known as turn ratio, or in other words we can say that transformer ratio. If for an ideal transformer the input power is equal to output power. Then let IP be current flowing through the primary coil and IS be the current flowing through the secondary coil. Then input power is equal to output power. IS ES is equal to IP EP. Or from this we can say that EP upon ES is equal to IS upon IP. This is suppose equation fifth. Therefore, this equation 5 and equation 4, we can conclude that EP upon ES is equal to ENP upon NS is equal to IS upon IP. Suppose this is equation 6, which is the generalized equation here. From this, we can say that if NP is greater than NS, that means EP is greater than ES and IS is greater than IP. Number of turns primary coil is greater than number of turns EMF in primary coil. That means step down transformer, and current in secondary coil is of in primary coil. And similarly, if we consider NP is less than NS, then we know that EP is less than ES, or we can say that current IS is less than IP. That means number of turns in primary is less than number of turns in secondary. We know that primary is also less than 3, and current flowing through the secondary coil which is less than the primary.